Hey everyone, welcome back to Code Streak Daily. Today we have a problem on linked list. It's delete alternate nodes and it's been asked in Morgan Stanley. Okay, and the difficulty level is easy. Now the problem is very easy. We have to delete the nodes alternatively. So let's see if it is a single linked list or a double linked list. Let's see that. So here we have the problem. um, it's a given a single linked list and we have to delete all the alternate nodes of the list, that is delete all the nodes present in even positions only. Okay, now here we have a linked list 1 2 3 4 and 5. In the list it is a length of 5 elements, and here at the even positions we have the elements 2 and 4. So after we delete that 2 and 4 elements, we will be left with 1 3 and 5. Okay, so we have to return this 1 3 and 5. So, and we have a second example here. Here we have a linked list of four elements. So the even positions hold 59 and 20. So we have to delete them and we have to return only 99 and 42. Okay. So here we have a time complexity should be in the order of n, where n will be the number of nodes in the list, and we have to aim to achieve this in the constant auxiliary space, meaning order of one space complexity. Okay, now let's talk about the approach first. We'll start with the head of the list and keep track of the current nodes. Then we'll check if there is a next node, like which should be in the even position. And if so, we adjust the next pointer of the current node to point to the node after the one we delete it. And we'll repeat this until we reach the end of the list. Once we finish that, the list will contain only the nodes that odd positions, right? Now, here we have the node initialization. um, we have the data part and the next part here. Self dot data is initialized with data and next is initialized to none. Here we have a class solution and also a function delete alt with a head passed as a parameter. So if we see here, there is other function called print list, which prints the list, and this is where the input is given. Okay, we don't need to bother about that. We just have to take care of this. We have to write the code for the function delete alt. Okay, now the basic condition which we need to check first is we have to check if the list is empty or it has only one node. Okay, like if head is none, or if head is none, it checks whether the list is empty or not. If head dot next is none, this checks that the list contains only one element, then we have to return, that's it. Okay, we don't need to do anything. Now next we have to initialize the current node as the head. Okay, I'm taking a variable called current and I'm initializing it with head. Okay, now our task is to traverse the entire list. Okay, so I'm taking a while loop. We can't take a for loop for a linked list. Okay, that would not be that would not be suitable. So we have to take a while loop and set a basic condition to traverse until the end of the list. Like if head dot next is null, or like while head dot next, so we can traverse till the end of the list. Like I'm taking while current because I have initialized the current variable with head. So while current and current dot next. Okay, so in this condition, now I have to skip the next node, that is node at even positions, right? So I am taking current dot next equals current dot next dot next. Now again I am moving the current node to the next node in the current list. Okay, I am taking current equals current dot next. So basically I'll tell you what's happening here. So basically what we have done, I'll explain you here now. um, Here we took a loop to traverse till the end of the linked list. It is a single linked list, right? I'm taking current dot next equals to current dot next dot next. Instead of deleting the nodes, we have done here is, you see here we have 1 2 3 4 and 5. Okay, as current is pointing to this element head, current dot next will point to second element, right? Current is pointing to 1, so current dot next will point to 2. Okay, So instead of pointing to 2, what I am doing here, current dot next equals current dot next dot next. Okay, so current dot next is 2, current dot next is 3. So I'm instead of pointing 1 to 2, I'm just pointing the 1 to 3. So there is no link between 1 and 2. The link has been broken by this line of code. Okay, now what I'm doing, current equals to current dot next. I have to move from here, right? So I'm making this current equals to current dot next. Okay, now I am here, and again I'll check current dot next equal to current dot next dot next. Okay, so current dot next is this. So I'm making current dot next dot next. So I'm pointing to 4. Instead of pointing to this, I'm pointing to 4. Okay, in this way, I'm just moving into the alternate positions. Okay, you understand, until the end of the loop. So this is how we will delete the nodes. Instead of deleting the function, we'll just break the link between the nodes in a linked list to delete them. So in our terms we are just deleting them, but in actual terms, in the coding terms, we are actually breaking the link between the nodes, because if there is no link between one element to another element, there is no way to access the node and the data. So instead of deleting them, we are just deleting the link between the nodes. That's how we are deleting the elements here. So let's see how the code works. Okay, compilation completed. Our output is 135 and the expected output is also 1, 3 and 5. Now let me submit and check if all the test cases will pass or not. Yeah, all the test cases have been passed and we have an accuracy of 100% and the time taken is just 0.17 seconds. So that's how we delete alternate nodes from the single linked list in order of n time and order of 1 space complexity. Okay, so as it is a single linked list, we are just moving in the alternate positions and making the current dot next equal to current dot next dot next. But if it is a double linked list, as we are breaking the connection between these two in a double linked list, we can traverse back also, right? So in that way, if we break the connection to forward, we also need to break the connection in the backward also. In that manner only, if we traverse in the both the directions, then we will not be able to access the alternate elements. Only that's the difference between a single linked list and double linked list deleting operations. Okay, I hope you understood well the concept, and I hope you all enjoyed this explanation and video. So don't forget to like, comment and do subscribe for more daily coding problems. If you want to keep your streak in both Geek for Geeks and also in Lead Code, do subscribe our channel, and if you have any queries or doubts, do put that in the comment section of this video. I'll surely check and reply on that. And if you have any code more efficient than this, do put that in the comments. I'll surely check on that. And keep coding, guys. Keep streaking.